Looking at the ammonium iron sulfate, and this is where the definition for primary standard goes in, so you get to write it again. So it is a primary standard. The formula is normally given, and it's a doozy. It is huge. So at this point, I'm going to remind you that in a question, in the body of a question, if they want you to calculate or a molar mass of something, this would be in bold. So this is a huge number compared to things we've done. And in a minute, you're going to have to be able to calculate it. So your primary standard definition, we've already done it. Pure, stable, soluble solid, weighed out, dissolved in water, solution of accurately known concentration, and anhydrous. So the other primary standard that you've worked with is anhydrous sodium carbonate. Okay, so we said that we have the sulfuric acid for the KMnO4, but when we make anything with iron, any solutions with iron, we have to add sulfuric acid to it. I'm going to change this word. I'm going to leave it as concentrated. And the reason we do this is, top answer to the SEC is, we want in our conical flask iron 2 to go to iron 3. We don't want it to go to iron 2 to iron 3 just when we're preparing our solution. So we add the sulfuric to prevent oxidation of iron 2 to iron 3 by oxygen in the air or oxygen in the water. So this is the top answer. And the SEC will accept occasionally it prevents iron 2 reacting with water, and it's a thing called hydrolysis when that happens. So we add sulfuric to the KMnO4 to ensure it goes from +7 to +3, purple to colourless. We add iron sulfate when we're making our solution of iron, and we're doing it to prevent oxidation of iron 2 to iron 3, because if we did that we would get a really low titer if we didn't put in the sulfuric, because it would already have changed by the time we'd get to titrate it. So what you wrote in is the KMnO4 blurb for sulfuric acid, and this is the iron blurb for sulfuric acid. So you are protecting the iron. You're making sure that when you do your titration, all you have is Fe2+ in your flask. Okay, so you will notice that for the preparation of our standard solution, if you actually flicked back and looked at the anhydrous sodium carbonate, it's pretty much the same things that we did. So if we were in lesson now, we would be using our ammonium iron sulfate crystals. We would be weighing out 9.8 grams of them. We would be making them up into solution in 250, following all the procedures that we're supposed to follow. And you would have to work out what is the final concentration of my solution. So you need to calculate a mass number for this, or a formula mass. Work out how many moles that is. We have 250. How do I turn that moles per 250 into a concentration? Go mad. Have we at least calculated our ammonium iron sulfate? So are we getting the number 392? Okay, so well done. That's one. So sometimes it's the 6 waters gets forgotten. People only put in 1 H2O instead of 6. So it should be 9.8 divided by 392. Should give you 0.025 moles. And how do I turn that then into a concentration? Or you can't see, thank you. So how do I turn that into a concentration? What are the units for concentration? moles per litre. So I'm going to have to multiply this by 4 to turn that into 0.1 big M. So big M is what they're going to have in a question, and that is the same as saying moles per litre. So there are a set of questions. So it says on page 125, go to page 141 in the write-ups. That is actually page 146. Pages obviously got moved around in the making of the book. So on page 146 there's a little write-up for making your standard solution, and it matches Chemistry Live on page 214. So I'm going to send you a notebook page in a couple of minutes that has the write-up for this little experiment for yourself and for the titration. There are questions on page 125, and there are questions kind of in the middle of page 126. I want you to read down through them now for me and ask if there's any issue with any of them. So page 125 we're talking about the ammonium iron sulfate, and on page 126 we are talking about the KMnO4. So the only one that I am, I suppose, interested in is that you're happy with the grey blackout answer, and that you're happy with how do you read the meniscus for this solution. You're happy with those as questions? Okay, thanking you. So if you just flip over to page 126, or at least is on mine where the little picture is. So just so that we know,
Yes.
yeah.
What's the grey one?
The grey one is, so the grey one is the protection of iron 2. So you want to prevent oxidation of iron 2 to iron 3. So that goes with the ammonium. With anything containing iron, we add dilute sulfuric. So we add it as we make our solution. So that's a real, they love to ask that question. Why did you put sulfuric acid into your beaker before you put your crystals in?
What's the other grey one?
So the other grey one is on the page 126. So it's why we add the sulfuric to the conical, and that's to ensure Mn+7 goes to Mn+3. So it's in the conical for Mn+7, or sorry, to Mn2+. So in our conical here, we are going to have the in our burette, we are going to have KMnO4 up here. Down here, we are going to have our ammonium iron 2 sulfate. And we are going to have H2SO4. Okay, and our indicator is the potassium permanganate 7, or potassium permanganate, and our color change, our color at the start, and by that I am talking about the conical flask. So it's the conical at the start. That is going to be colorless, and when you are finished, at your finished, you will get that first permanent pink. So what I'm going to ask for you to do, because I don't think you want to stay here with me and watch the video, because it's going to be too tinny is the word I'm looking for. So what I'm going to do is I'm going to send you the link with the PDST version of the Chemistry Live, the titration, and I'm going to ask you to do your little write-up on page 146, do your write-up for the titration on page 148, and answer the questions on page 125 and 126 for me. If I'm going to send this now, so I'm going to stop recording.